Namaskar, my dear friends. Let us see how we can design active high pass filter. So what we'll do is we'll design first order high pass filter using active element like op amps. Okay. So as you know, the high pass filter response is something like this. Let's say it starts from this. So this is the purple color that is there. That is high pass. So before that, this will be a stop band, and after that, this is going to be pass band, which is like frequency will be allowed in this. And the little bit bluish color, it is actually ideal filter, sharp, like a cutoff it is there, you can see a square. So designing like this filter will be little tough because first order filter will be little over rolling kind of thing. However, very high order filter you can come closer to ideal. Okay. Using RC element, we have already seen that high pass filter will configuration will be actually like this. Okay. First there will be capacitor, and then there will be resistors. Okay. So this is how high pass filter look like, and the cutoff frequency becomes 1 by 2 pi RC. Similar to that, using active element, what we are going to do is we are going to design using op amps. So you can see we have RC element here that is going to decide the cutoff frequency for high pass filter, and then R2 R1 is going to decide the gain of the filter. Okay, so you can see the gain will be 1 plus R2 by R1, and the cutoff frequency for this will be 1 by 2 pi RC. If you want to find out why it 1 by 2 pi RC is coming, you can write down the transfer function that you can refer in my theory videos how to get all these expressions. Right now here we are going to simulate this high pass filter to get the Bode plot and magnitude plot of this particular high pass filter. All right. Okay. So as you can see, a very simple high pass filter I have designed here without any gain. Right now it is only a single gain, like it is a buffer circuit kind of thing. The value of this capacitor and this resistor will decide the cutoff frequencies. As you can see, zero point 0.1 microfarad and 1 kilohertz kilo ohm is going to give you an output around, like minus 3 dB frequency will be at around 1.59 kilohertz. So after 1.59 kilohertz, this is the high pass that you can see. So almost 0 dB everywhere. Okay. So this is the magnitude response, and this is the phase response. So this is the circuit that we will be practicing and seeing the output at this particular place where it is giving you high pass output or not. Now this is the input signal, and this is going to be at output, right? So I want to, pass my 10 kilohertz signal to this high pass filter. How does it respond? Okay. So let us see how does it respond is this signal is going to go through this high pass filter, which is just 1.59 kilohertz, and in that what will happen? The green color is input signal VPR2, right, probe 2, and the red signal is output signal, which is almost following the input. So that's the reason it is my good design. Now let us open Multisim and try to simulate this. Okay. So for that, what you have to do, you already know how to place, like components. So I have placed one op amp and one, power supply VCC and VEE, right? And then let us say I'm going to just place one probe at output PR1. Let me make this capacitor as C1 so that, like it will be easy for you guys. Let's say, oh, sorry. I will remove this and place component again, basics, then capacitor, and then put it here. So naming will be better. Okay. Now make it, let's say, 0.1 microfarad. Now what is going to happen? How do we decide what is the cutoff frequency for this? So you know already 1 by 2 pi RC you have to set. So 0.1 microfarad and 1 kilo ohm. Let us open Excel sheet. I am going to 1 kilo ohm and zero point 0.1 microfarad. So what is the cutoff frequency? 1.59 kilohertz. That is 1591 hertz. Okay. So 1.59 kilohertz should be the output. So let us simulate and see. Go to simulation, analyze and simulation, come to AC sweep. Then let us say we can set it 10 megahertz is fine. This decibel is fine. Now let us run it. So you can see this particular place, it is going to start like minus 3 dB frequency will be 1.59 kilohertz. So let me measure and show it to you. So I'll just increase the thickness so that you can see it very properly. And this one is also right. Now show cursor. So cursor is shown, and I'll just drag my cursor. So you can see y2 is minus 11, minus 9, minus 3 it should go, and it should reach to 1 point this much, minus 3. Yeah. So 1.59 kilohertz you can see, minus 3 dB almost, it is 1.57 it is showing, but 59 it can be, not a problem. So this is how you vary your high pass filter. Now why don't we do one thing? We will design 1 kilohertz high pass filter. So 1 kilohertz high pass filter, what shall we do? Let us put 1 kilohertz our requirement. So our capacitance, let's say we'll put it 0.1 microfarad only. Then what will happen? My resistance value will become 1.59 kilo ohm. Okay. So to set 1 kilohertz cutoff frequency, our RC will be set to how much? Tell me. My C is 0.1 and R will be 1.59 kilo ohm. Okay. And you will see the cutoff frequency has shifted to 1 kilohertz. Okay. So let me run and see. Let us run it. So you can see my minus 3 dB cutoff frequency will come to 1 kilohertz. So let me drag it and show you minus 3 dB, right? So 3.1 it is, minus 3.1, 972. So if you make it minus 3 exactly, it will come 1 kilohertz, not a problem. So I hope you have a good understanding of how to design active high pass filter with particular cutoff frequency of your requirement. Do you want to do any other changes? Let us say I want to make it 10 kilo ohm. So what will be the cutoff frequency for my filter? It will become 159 hertz. So more than 159 hertz, all the signals will be passed. Understood? So in that case, what we can do is let us make it 10 kilohertz, 10 kilo ohm. So the cutoff frequency will reach to 159 hertz here at this place. So let us run it. Yes, it has reached. So cursor, and you can see my cutoff frequency is at 159 hertz. So I think you are now getting an idea. See, exactly minus 3 dB, 159 hertz. Understood? So you are getting an idea how to design high pass filter and vary the values of our resistors and capacitors to get our desired output frequency. Now if I want to see the waveform output, okay, so waveform output, what you can do, you can quickly go and analyze and simulate, and let us say we will run transient, okay, and let's run it. So you can see my output signal is very nicely 1 volt and minus 1 volt it is coming, 1 volt peak, right? Why it is coming? Because the high pass filter is 159 hertz. Okay. Even if you make it 1.59 kilohertz, then also it will be same, because it will not change any. Little bit reduction is there at the startup, and what was your input signal, that also you can see. Okay. So my green signal is actually, like input signal, the green color. So let us increase the thickness and show it to you very properly. And the red one is output, which is going to be following the input signal. Okay. Now, what is the cutoff frequency for this? 0.1 microfarad and 1 kilohertz. Let me check here. 0.1 microfarad and 1 kilohertz. The cutoff frequency is 1.59 kilohertz, right? So if my signal frequency is less than 1.59 kilohertz, let us say I'm going to send, let us say 100 hertz. So this 100 hertz signal will not pass. Why? Because high pass filter is designed for 1.59 kilohertz. Means signal must be more than that. Okay, so let us see and see, it is not the red signal which is my output is not allowing to pass. If you want, you can simulate for longer time and see, because the frequency is less. So let us say 10 millisecond will run. So see, the input signal is very nicely, you can see green signal, and the output PR1 is not passing. Got it? So your aim must be design the filter which is whose cutoff frequency is less than the input signal. Okay, so what should be the cutoff frequency of high pass? Less than 100. Why don't we do one thing? Let us say we set our cutoff frequency to 10 hertz. So, and this one I'll just make it, let us say okay, let me make it 22 220 nanofarad. Okay, then 7.72 kilo ohm. Okay, so 0.22 and 72, if I do this one 0.22 microfarad. Okay, and this is 72 kilo ohm. Okay, then the cutoff frequency is around 10 ohm, 10 hertz. So my input signal is more than that, so it will pass. So you will see, let us run it. See, my red signal is following the output signal. So this is how you design your circuit in such a fashion that your required input signal is allowed to pass to the output very nicely. So hope you have a good understanding of how to design the high pass filter with active element, and how to select your op amps and all these things. If you want, you can quickly go to place, components, then analog, and then come to op amps, and here you can write down OPA elements are there a lot. Okay, so OPA series op amps you can utilize some of them. That's what I have done. Okay, that's all guys. One more thing what you can do is, if you want to have gain on this, okay, so how do you do? Simply you have to place in the feedback. So as you know already that I had showed here R2 and R1 to set the gain, right? So to do that quickly, what will you do? Go to place, components, and go to basic, and then place resistors. So two resistors I am going to put here, one here and one more here. Okay, and let us define the gain. So this will be at this location, and this one I'll have to delete like this, and let's say connect it again. Yes. Now, what gain do you want to set? So let us say my input voltage is 1 volt peak. My output should be 3 volt peak, let us say. So I'll put it, let us say 2 kilo ohm. So 2 by 1, that is 1, plus 1, that is 2. So, oh sorry, 2 by 1, that is 2, plus 1, 3. So gain will be 3. So my output will be 3 volt peak and 3 volt drops, right? So let us run it. So you can see output is reaching up to around 3 volt and minus 3 volt. Understood? If you want, you can have proper like a filter design. So let us say I'm going to put a standard values, 0.1 microfarad and 1 kilo ohm. So 0.1 and 1 kilo ohm was, what was the value? 1 kilo ohm, 0.1, that is 1.59 kilohertz. So my input signal should be more than 1.59 kilohertz, that is, let us say 5 kilohertz. In 5 kilohertz our simulation setting can be, let us say I'm going to run for 0 1. Okay, 1 millisecond I'll run, or yeah, 1 millisecond is fine. So you can see the green signal is 1 volt peak. Okay, and the output signal, which is red signal, which is going to be 3 volt peak. So it is reaching up to around 3 and minus 3. All right, so you have a good understanding of complete design of high pass filter with gain, without gain, and changing the input frequency and changing the cutoff frequency of high pass filter. So whatever was the requirement that is needed for designing the high pass filter, I have explained you. If you do have still any questions or any other requirement, you can put down your questions in the comment box and we shall be able to answer you out. Thank you.